perpendicular to the base. So the base at the 12 is perpendicular isn't going to be 16. It's just the 14. So the area of the triangle here is 1/2 base times height. So it's 1/2, 12, and 14. Otherwise known as, what is it, 84 square inches. 2, well, 2 is a real difficult one to figure out what you're looking at. Appears to be a trapezoid. We have a trapezoid with a vertical height of 7, a base of 15, and a base of 9. It's nice when you don't have to actually do a little bit of extra math. All you're doing here is just direct substitution. We have 1/2 the height, sum of the bases, and you quite literally type that into your calculator, and you'll get 84 square inches. Not to say that every problem that we do is going to be 84 square inches. It just so happens that the first 2 that we do are 84 square inches. Second one, or third one, excuse me. Had a lot of people brain fart on this. A lot of people brain fart on this one. AC is the what of, well, first of all, what shape is this? What? Is there such a thing? It's a rhombus. It's a rhombus, okay? It's a rhombus because it's got all 4 sides congruent. Now, when you have a rhombus, that means you have all 4 sides congruent, and then that also means that your diagonals are perpendicular. The diagonals also bisect each other. So if I've got a side length of 17, if this entire diagonal is 16, that makes each of them 8s, which means you have to figure out the length of one of the other parts of the diagonal. Gee, I wonder how you're going to find the missing side length of a right triangle given 2 side lengths. Skip it, yeah, just say IDK and then go to the next problem, right? 8 squared plus something squared is 17 squared. Well, hey, that something is 15, which means the other something on the other side is also 15. Now, the area of a rhombus is equal to 1/2 diagonal 1 times diagonal 2. Well, in this case, our diagonals are, well, 1/2 of 16 times 30. And then, what is that? 240 something squared? And something squared. Okay. Wait, not 240, I'm sorry. I did 240, then I did that one. Oh, I was right. Sorry. Number 4. Oh no, what is that? I can't figure that out. That shape is so difficult to understand. Please help me, my weary eyes, for that I am old and unknowing of shapes. What is it? Pretty sure it's not a trapezoid. I'm kind of thinking it's a parallelogram. Look at that. And we know it's a parallelogram because you've got all these thingies going on. So if I look at my handy dandy fancy schmancy formula sheet, it tells me that a parallelogram has an area of base times height, which means this is 32 something. I know that was hard. Good luck. No, I have faith in you. You can do it. Hey, look at this. How many times have you done a hexagon? Too many times. So we have a regular hexagon, side lengths of 10. Hey, that means when we draw our 3 sides. Hey, look at that, 3 sides. Apophone, perpendicular bisector. If you have sides of 10, that means each of those are now 5s. Draw the radius in. Figure out our exterior angle. Figure out our exterior angle. In this case, our exterior angle is going to be 360 divided by 6, and you get 60, which means this winds up being 60 in here. Now you can do one of two things. You have a 30, 60, 90 triangle, which means you can use the ratios, or use the trig to figure out the azimuth. Well, if I know that across from my 30 is 5, that means across from my 60 would be 5 root 3, or guys do sines, cosines, tangents, whatever you have to do. Right. So now you got everything. So your formula is 1/2 perimeter apothem. Well, it's 1/2 6 sides of 10, and an apothem of 5 root 3. 150 root 3 something squared. Okay. Again, we have done the perimeter apothem problem at least 7 times. And it's, yeah, that's sarcasm is strong with me right about now. Yeah, that's pretty awesome to draw on. Oh yeah, this is so to scale. And missing eyesight. Now, this is a composite figure. Easiest thing to do here is to draw it out as a rectangle plus a triangle. Okay. Now the rectangle is easy, 120 by 60. The triangle, well, since I've cut out 60 here, that means this portion is going to be 200 to subtract that, which is 140. The other height here is going to subtract out the 40 from 120, which is 80. So I'm going to get 1/2 80 times 140. Press a whole bunch of buttons, and I get 12,000. Thought I did. Unless I read it wrong when I wrote down my numbers, which is completely possible. Come on, it's the last week of May. You can probably find a pencil for class now. Pretty sure they're not going to like that now. Use the diagram to write to solve the problem. So the next one, we've got circles. Yo. Yeah, I did what's half 80. That's okay. No, I just did that quickly because that way I have to do the fraction bar and all that kind of stuff. No, it's all right. Don't worry. No. It's by yeah. It's I did send that quick simplify on there on that. What's up, Lance? What did I type in? Oh, I did a. No, you do half. Oh, I see. I did 120. Thank you. Thank you. Everybody see that? I typed in 120. And then you're like, oh, you did the 40. I'm like, yeah, I just did the. I didn't. Yes. Sorry about that. I typed in 120 here, guys, instead of 140. So, yeah, it would be that. When were you guys getting 1280? 12800? Sorry about that. There you go. I had it all written down. Yeah, I even wrote down on here 120 by mistake. Oh, you know why I did that? When I did my side lengths on my diagram, I looked at this being the 80, and I subtracted 80 from 200, as opposed to the 60 that was already written next to it. So it happens, right? Look at you! I just noticed you got the braces off now. How's that working out for you? Weird? Oh yeah, those take. Oh yeah, wear that. That's not bad. That's not. It really is not that bad. All right, circles. All right. Circumference. Well, how do you find circumference? Well, according to your fancy schmancy formula sheet, circumference is 2 pi r. Well, radius here is 27. Double it, and you get 54 pi. Here's the first part. The length of AB. Length of AB, bless you, that stands for arc length. That's what that means. Use the formula. Central angle over 360 times 2 pi r. Well, our angle is 40 over 360, bless you, times our 54 pi. Well, you can put all that in the calculator, or realize that zeros drop. 4 goes into 36 how many times? 9. Bless you. 9 goes into 54 6 times, and you get 6 pi. That's your arc length. Or press buttons in the calculator. Bless you. Apparently, simplifying fractions is an allergic reaction to some of us. Area of the circle, just pi r squared. So it's 27 squared pi, you get 729 pi. Man, I gotta get out of circles. And then the area of the sector is just the central angle over 360 times the area of the circle. You should get 81 pi squared. Which one? I use the formula. Central angle over 360 times the area of the circle. So the angle is 40 over 360 times 27 pi over 2. 27 square pi. So we just found the area of the circle, which was 729, and I multiplied that by 190. 11. People are freaking out about number 11. I'm not exactly sure why. Wow. Great. So what they have us doing here, let's see if I can get this to shade correctly. Gotcha. Just let me fill it. Anyway, so here's the shaded. Here's the shaded. It's 4, 3, and the whole thing is 8. Find the area of the shaded region. Well, area of the shaded region, isn't that just triangle?
Isn't that just a triangle? When you have a triangle, well, what's the height of the triangle? What's the base of the triangle? 4. Because when you look at your sheet, if you take this and try to find the area of the shaded region, if you just fold that page in, sorry, it doesn't want to fold right. If you just fold that over on itself, the shaded region, it's just a triangle. You just got rid of that space of 4 in between the two. That's where we get it. Okay. 12, circles within circles. What's that? Oh yeah, we did that one. Okay. 13 is the geometric probability. So that's when you have to find the area of the shaded and then divide it by the total area. So geometric probability here, same basic idea. You'll notice that you've got that fold over. So your area of the shaded region. Well, the shaded region happens to be a triangle with base and height of 6 and 3. Okay with that? So it's 1/2 6 times 3, which is 9. The whole thing of the total is a trapezoid. So the whole thing has the trapezoid of 1/2 height of 3, base sum of bases of 18. So that one winds up equaling 27. So your geometric probability is the shaded region over the whole region, otherwise known as 1/3. Next one, you have a parallelogram with a circle cut out of it. Well, area of the shaded region, the area of a parallelogram, subtract the area of a circle, divide that by the area of a parallelogram. Well, parallelogram has formula of base times height. Well, your base and height are 4 and 11, or 6 and 11. To that, you have to subtract the area of a circle. Well, the circle has a diameter of 4, which gives it a radius of 2, which means its area is. Yeah, so the area of that one happens to be 4 pi. No, it's not wrong. What's 2 times 3? What's 3 times 2? It doesn't matter. It's just it's proper what we call mathicate by just putting it in last. So in your calculator, all you have to do then is 66. We'll make a fraction bar. 66 subtract 4 pi. Divide that by 66. And then there's geometric probability. Excuse me. The ratios of the side lengths of two similar polygons are 5 and 8. The area of the smaller polygon is 125. Find the area of the larger. So we had similar figures. What you wound up was you had sides ratio, which gave you a scale factor. Then you had an area ratio, and then a volume ratio. And what we did here is that they all follow the same pattern. There was a pattern to it. If the ratios of the sides were in A to B, that meant the scale factor was A to B. That then meant that the area ratio was A squared to B squared, and then the volume was A cubed. Okay. So when you're looking at ones like that, you're
using that bit of information. So it says the ratio of the side lengths, the two similar polygons are 5 and 8. That means your side ratios are 5 to 8, which means that your scale factor is 5 to 8, which means your area ratio would be 25 to 64. So then I would use that ratio. Since the area of the smaller is 125, find the area of the larger. Well, which of these is smaller? 25. So what we do is just have a cross multiply problem of 25, 60, just something. Let's see, multiply it by 5, we get like 0, 3, 320. Yes. 320 square inches. I wonder, I didn't do this problem yet, but I wonder if there's supposed to be volume. What are these volumes? Let's see what this does. Okay. This one was labeled incorrectly. See, it's supposed to be feet squared. 27 square feet, 147 square feet. Not feet cubed. Because if it was feet cubed, the numbers wouldn't be clean at all. Right. So number 16 is supposed to be 27 feet squared and 147 feet squared. Not cubed. So what we do here, same idea. Here they're starting with these. Here they're starting with the area one at 27, 147. And now they're trying to figure out the side length of the larger is 35, find the corresponding side length of the smaller. So that means that I'm going to side length, so I have to work my way to the left. So first thing I do is I throw the 27 over 147 in my calculator, like I just did, and I hit enter. That simplified that out to being 9 over 40. So that is the simplified ratio of the areas. To get to the area, to the ratio of the scale factor or the ratio of the sides, I have to take the square root of that. So remember, I'll take a square root of a fraction that's already in there. You get second square root of your answer. You get 3/7. So your corresponding side length stuff will be 3/7. 7 times what is 35? What's 5 times 3? Your answer. There's your answer. Now, some of the other things that we did with this one, it's one of those chapters that a lot of you guys gave mistakes. You don't have your chapter 8 test. I'm going to show you this. So, chapter 10, one of the problems that we had to start with in the chapter 10 test was to find the area of this. And this was number 2 on your chapter 10 test. And what this problem did is that it served as a multi-part question that we've done over a couple of different chapters. So when you see something like this, which you probably will again because I'm spending time on it, bless you, bless you. Obviously, we have to do a trapezoid here. So we know we have to do the area of a trapezoid. 1/2, bless you, height, sum of the bases. I know one of the bases. I know the height. I have to figure out the other base. Well, I know then if this is 7, from here to here is also 7. If this is 4, that means this height here is 4, which means opposite the other 45 has to be 4. And then I got to figure out that one by using Pythagorean theorem. Right? So you had to do a couple of parts to get to a part to this one. 5 squared, subtract 4 squared, take the square root, you get 3. So that means your whole bottom base is 14. You get 14. Number 3 on that test is exactly like the question we just did in the review packet where they gave you, it was a rhombus, and they gave you a diagonal and one side length, and you have to figure out the other side length using Pythagorean theorem. The 4th one on this when we did this, so when we did one like this, find the area of that, well, that looked really, really weird until you realized all this problem was this part had been cut out of this part, which makes this a rectangle. The area was 6. Working backwards style problem, find the area of a circle with a circumference equal to 32 pi. This is a very common style problem. Again, it's formula, but you have to know how to set it up. So if you've got circumference, and you got to find the area of the circle, well, circumference allows you to figure out the radius. If circumference is 2 pi r, and it has to equal 32 pi, well, what's pi divided by pi? It's 1. What's 32 divided by 2? Again. That gives you a radius of 16, which means then you use that radius into pi r squared to get the area. So 16 squared pi, 256 pi. Something squared. Guys, the combination of style problems it's not just pure, here's the radius of the circle, find the area. It's here's the circumference of the circle, find the area of the circle. You have to be able to do multiple parts. Also here we did a decagon and an octagon. Again, if you've given perimeter, you've got to draw your 3 sides. Is there any pi involved in any regular polygon? No. You think you should have pi in your answer if you have a regular polygon? People go pi in your answer. You'd be surprised. I forgot. Yeah, so you got stuff like that with chapter 10. A lot of it, guys, it's the attention to detail that obviously nobody's half of them are paying attention to anything I'm saying right now anyway, so man, you guys are gonna have a good time next year. But yeah, we'll go through volumes and surface area stuff tomorrow. Make sure you get all that done as well. But yeah, guys, have your tests and quizzes going because I'm going to pull some of the stuff out on there because quite a bit of that. All right.